This recording is the first recording of several different recordings from our last unit of distance learning here, where we're going to take a look at different ways of displaying data and analyzing data. In previous lessons, we've talked about, what does a statistician do with their role as a statistician? What do we do? And we've talked about that you start with a question that needs to be answered. And then as a statistician, you're supposed to be the expert on gathering data, so you gather the data. And then do you remember what the third step of the process is? So we've got to gather the data, and then this is where we study the data, we analyze the data, and we try to make sense out of all that information that we've gathered. So what we're going to talk about then for the remainder of the trimester are different ways that you can analyze the data. And there's a lot of things you can do to start analyzing the data. One way to analyze the data is with what's called measures of central tendency, measures of center. The word central here, if you think of the word, it means the center. So we're talking about, wow, that was poor penmanship, but measures of center. Where does the data tend to gather together? A lot of times in the world of statistics, we gather tons and tons and tons of data, and it can get confusing. So one thing we can do with our statistical analysis is, kind of shrink the data down a little bit to add some clarity to it. We call that a macroscoping technique. Take a lot of data, shrink it down a little bit. And let's look at an example. So this is a little confusing because there's 10 students and they took a 10-question quiz. Here's the first group of students, 10 of them, and they did the quiz. And here's a second group of students, 10 students, and they took the 10-point quiz. Get it? Which group did better? Group 1 or group 2? I've asked that question of a lot of students in the past, and I always have students that say, oh, group 1 did better because look at that. Everybody, if 60% of the points is passing, all 10 students pass the test. Other students say group 2 performed better because they had 3 students that had perfect scores on the quiz. And there's a lot of ways to describe the results here. And you can argue, like those students did, that in some of those arguments, group 1 did better. In other arguments, other ways of looking at the data, group 2 did better. And so I guess the moral of the story is there's different ways to describe the data. And in measures of central tendency in our lesson, we're trying to describe where the center of the data is. Where's the middle? Where does the data tend to gather together? Where's the central location? And we can see the center by graphing the data. On the left, you'll see a stem and leaf plot, and I can see that most of the data falls in the 70s, mid-70s. Here's a dot plot over on the right, and I would describe the middle of the data to be somewhere in that area. Here's another dot plot. It looks like the data is tending to gather together in the middle here around a value of 8, 9, or 10. But again, measures of central tendency are measures of center, measures of middle. There's 4 pretty common measures of center, but with the lack of time here, we're going to look at 3 of them. And the nice thing is, you know these 3 already. We're not going to look at mid-range, So we're going to look at mode, median, and mean. And you're feeling more comfortable with this now, right? Those are measures of center. Those are measures of central tendency. So I'm not going to insult your intelligence. We're going to go through this pretty quick. So mode, I've worked with students for a lot of years on this. I know that you know that mode is the most commonly occurring value, the one that you see the most, the mode, the mostest. So mode is a measure of central tendency where you describe the most commonly occurring value in the data set, the one that you see the most of. So question, what if there's two numbers tied for the most common? What if your data set is 3, 10, 13, 16, 16, and 20? What's the mode now? Most mathematicians would say then that both of these numbers, 10 and 16, are the mode. So if you had to list the mode, you'd list both numbers, 10 and 16. It's bimodal. If it's a three-way tie, it's trimodal. And if there is no number that occurs any more often than the others, then there's no mode. Can you believe some mathematicians argue that every number is the mode in that situation? But I'm going to say no mode. So there might be one, might be two, might be three, might be a whole bunch of modes, might not be any. In this data set, I'm kind of looking quickly. I see two 15s, I see two 11s. I don't see anything else that occurs more often than twice. So I would say 11 and 15 are the mode. This data set is bimodal. Oh, okay, never mind. We'll skip the rest of that. So along with the mode, the most commonly occurring value, we also have the mean. Technically, the mean is the arithmetic mean, but we say mean. And quite often, we don't even say mean. We say the average, right? So the average is the mean. And I'm not going to insult you because I already know that you know how to find the average of a bunch of numbers, right? Add them up, divide by however many numbers there are. So I don't think I need to say much more about the mean, other than possibly that in the world of statistics, there's two symbols that are commonly used for the mean. This is the population, here's a small sample group. If we do a census and gather data from everybody in the population, the symbol for the mean is the Greek symbol mu. Mu. And it's actually like an M, but it looks more like a U with a tail on it. But the symbol mu is commonly used for the mean. And if the data came from a small sample, then the mean of that data is represented with an X with a little bar over it, X bar. So if you're reading statistics books, mu and X bar are both symbols for the mean, the average. Okay, so we've got the mode, we've got the mean, then our third measure of central tendency is the median. And you've calculated median before, right? I looked up median in the dictionary, and the dictionary said you got to do two things. Put the numbers in order. It's important to put them in order, right? And then if it exists, pick the middle number as the median. If it exists. And they're like, what? What does that mean? Well, if there's an even number of values like this for the median is going to fall halfway in between 4 and 5. So you add them up and divide by 2 to get the average. So it's kind of weird. Sometimes to calculate the median, you have to find the mean of the two middle numbers. Now, I've worked with students, like I said, a lot of years. Let's see, four, what do we got? Six. I'm putting these in order, right? 8, 9, 10, 10. And I've seen that students do the old cross them off kind of thing. You know, cross off here, cross off these, cross off this pair, and the median is 8. And then one more of those, one more of those, 29, 36, 36, 42, whoop, 41, 42, 48, 52, 54. Okay, now, can you believe, I'll bet you can believe this. Can you imagine this? That some people, you know, cross this one off and then this one, cross this one off and then this one, cross this one off, cross this one off, cross this one off, and the median is 42. Can you believe that baloney? You guys know that when you're crossing numbers off, you cross them off in pairs, right? 29 with 54, 36 with 52, 36 with 48, and you end up with two middle numbers. So the median here is not 42. You got to add them up and divide by 2 and get 41.5 as the median. So we're not going to do mid-range. So we've kind of hit them. Our measures of central tendency, we're not doing 4. So it's mode, mean, median, easy to remember, 3 M's. What are the measures of central tendency used for? The root word right there. They find the center where the data gathers together in the middle. Mode, mean, median. Pretty easy, right? Can I add one other little topic? Can we move on to one other little thing and then we'll be done already? Here's 5 numbers, 12, 18, 19, 21, and something. The average, the mean of those numbers is 21. What's the value of that number? I wish we were sitting together in a classroom right now. We can talk about that. But to find that number, think about what you do to find the mean, to find the average. You add them all up, right? You get the sum, and then you divide it by the number of numbers. Add them up and divide however many numbers there are, and you've got the mean. Right? Okay, so I'm going to slide that up a little bit. So now I'm going to do a little bit of algebra here real quickly, try to do it fast. I'm going to multiply the left side of the equation by the number of numbers. And I'm going to multiply the right side of the equation by the number of numbers. And on the left side, if I divide and I multiply, they cancel each other out, right? And on the left side of the equation, I've got the sum. And on the right side, I was taking the mean and multiplying it by the number of numbers. And this is a really, really important idea, right? That if I know what the sum is, based on this, I know what the sum of numbers is if I know these two values. If I know the average and I know how many numbers there are, I also know what they add up to. Let's go back up here. If I know the average is 21 and there's going to be 5 numbers altogether, I can go 21 times 5, which is 105. These numbers have to add up to 105. Now it's a piece of cake, right? So I'm not even going to finish that problem because I don't want to insult you. So we go on, and here's another one. There's an unknown value, but I can see altogether there's 6 numbers, right? And I've got the mean. So the sum of the numbers, the sum of all 6 numbers, is going to be the mean, 15.5, times the number of numbers, 6. So I could take my calculator and go 15.5 times 6, which is 93. These numbers have to add up to 93. And actually, I'm going to finish this one. 7 and 13 is 20. This is 39. That's 59, right? Plus 12 is 71. These numbers add up to 71. The red numbers add up to 71. So let's see. 93 minus 71 leaves 22. I think that number's got to be 22, so that they add up to 93. We're almost done. Last really quick example. The mode. Here's 10 people. They all work for a company. They're all getting paid the same salary. What's the mode salary? My grandma knows that, right? 50,000. What's the mean? If you added those all together and divided by 10, you're going to get 50,000. Okay? What's the middle number? Well, there won't be a middle number, but you have to go halfway between 50,000 and 50,000. So you add up 50,000 and 50,000 and divide by 2, you're going to get 50,000. And so in this example, the measures of central tendency are all the same value. That will happen always when the data is all identical like that. 50, 50, 50. So they all give you the same measure of center. Now, the boss of the company, Warren Buffett, you know that guy, right? Warren Buffett. He pays himself a salary of $3 million. Okay, now we've got 11 numbers all together. What's the mode? By far, the most common number, 50,000, right? The mean, I've got to add all those numbers together. 500,000 would be the total of all of those 50,000s, plus 3 million, and you're going to have 3,500,000 divided by 11. And I just did that on my calculator. The mean is 318,181 plus a few cents. The median, the middle number, if you put them all in order and grab the middle one, it's 50,000. Now look at those measures of center. Can you see, I hope you can see, you can see, can't you, that the mean does not do a good job of describing the middle anymore? The mean, as a measure of central tendency, does not do a good job of finding the middle when there is what's called an outlier, or there might be outliers. An outlier in the world of statistics is a number that really doesn't fit with the other, an outlier is a value that really doesn't fit with the other data. And in this case, the salary paid to Warren Buffett by himself is an outlying value. And an outlier destroys the mean. It skews the mean. It pulls the mean up artificially closer to the outlier. And so the mean doesn't do a good job of describing the center anymore. The fancy way to say that in the world of statistics is the mean is non-resistant to outliers. So the moral of the story is the mode and the mean and the median are all supposed to describe the center, but they all can be misleading at times. And the mean is definitely misleading when there's outliers. So you should keep that in mind when you look at data. So I think we've covered everything that we needed to. The measures of center, mode, mean, median, they're all supposed to describe where the center lies. They can all be misleading at times, right? Especially the mean when there's outliers. And then you now know how to find the missing number if you already know the mean and the number of numbers. So that was pretty fast, but you can handle it, right? Mode, mean, median. Hey, which of those do you have to have the numbers in order? Yeah, the median. Median, you got to get the numbers in order. So that's it. That's all, folks. So check the Schoology page for probability and statistics. There's a lesson there called Measures of Central Tendency, and there's 6 or 7 exercises for you to work on an attached worksheet. So that's the end of this video.